right, so we're going to take a look at a few more examples of recursive sequences. So this next one is a1 is equal to 6, comma, an is equal to an minus 1 divided by n. So similar to the other one where we had n as part of our question, we will be doing 5 terms again this time. So remember, an minus 1 means previous term. We know our first term. So that means a2 is going to be the previous term, which is 6. So 6, I'll just write it as a1 divided by 2. So remember, the 2 you want to match up with whatever your n value is. So in this case, we're doing 6 over 2 or 3. We're doing 5. I'll give a little space. I'm going to write it down underneath. So 6, comma, 3, comma, a3 is going to be the previous term, which is a2, divided by 3. So we're going to be doing 3 divided by 3, which is 1. 2 more. Fourth term is going to be our previous term, so a3 divided by 4. Now again, I'm writing all of this out. You don't have to write this out if you recognize what you're doing here. But I'm just showing you what I'm doing each of the times. And the last one's going to be a5. Oops. Which will be the previous term of a4 divided by 5. It's really 1/4 divided by 5. You can multiply by 1/5. You can use the fraction tool. You're going to get 1 out of, oops, I wrote 12. You're getting 1 out of 20 for the last term. I'm just going to move this sequence down a little bit because I kind of squished it in. So that will give you the first 5. And listen, if you're comfortable going right to here, I'm fine with that, but it might help you to write out what you're doing to help you with that previous term idea. Fifth example, a1 is equal to 2, an equals n squared minus an minus 1, minus the previous term. Okay, so same result. Let's go right into a2. a2 is going to be 2 squared minus a1. So minus our previous term. a3 will be 3 squared minus the previous term of a2. a4 will be 4 squared minus, now I'm not going to keep writing this a2, a3. I'm going to go back and just do the previous term. So 4 squared minus 7 is 9. a5 will be 5 squared minus the previous term of 9 is equal to 16. And then I'll just write it out in the horizontal sequence format once I get those values. Now we're going to backtrack a little bit and talk about our arithmetic geometric series or sequence. We're going to write an explicit rule for each recursively defined sequence. So for 6, we have a1 is equal to -5. an is equal to 4 times an minus 1. This is a geometric because we are multiplying. What I would recommend doing is maybe writing out a little bit of it because you were comfortable seeing it written out. After you do this the first couple times, you may not need to do this every single time. So if my first term is -5, I'm going to multiply that by 4 to get -20 for my second term. And then if I multiply -20 times 4, I get -80. So there's my sequence. I can see my common ratio of 4. I can see my first term. Remember, for the explicit rule, we're just changing it over into a1 times r to the n minus 1. You really have all that information up here, but if you write out the sequence, it might help you see a little bit better what you're doing. So it'll be negative 5 times 4 to the n minus 1. And if you do that a few times, you might be able to skip this step right here after a little while. And then we have our arithmetic sequence. A1 equals 7. AN is equal to AN minus 1, previous term, plus 3. So because we're adding or subtracting would be arithmetic. So again, I'm going to write out a few terms. The first term is 7. The second term would be the previous term plus 3, so we would have 10. And then we'd add 3 again. Just so you can see, okay, I'm adding 3 each time. I know that this is my first term. And we're using the explicit rule for the arithmetic formula, which is A1 plus D times n minus 1. Again, if you feel comfortable going right from here to here and translating that over, go for it. But if you don't recognize which type of sequence it is at first, write out the first few terms like we were doing in examples 1 through 5, and then you'll see the kind of sequence you're working with and be able to write your explicit rule. So that's it for the videos for the recursive. It's now your turn to try the practice that goes along with this.